Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So to solve this, I'm going to first start by rewriting 15 as 3 times 5. So now I have 3 to the power of x times 5x squared, 5 to the power of x squared is equal to 3 times 5. Now, I'm going to divide both sides by 3 to the power of x, as well as 5. So then, for my left-hand side, both the 3 to the power of x's cancel out. For my right-hand side, both the 5's cancel out. So now I get 5 to the power of x squared over 5 is equal to 3 over 3 to the power of x. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 5 to the power of x squared over 5, that's the same thing as 5 to the power of x squared times 5 to the power of negative 1. And now this is equal to 3 times 3 to the power of negative x. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So, in this case, I get 5 to the power of x squared minus 1. And now this is equal to 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can move this exponent and b to the front, so it's going to equal b times log a. So in this case, I get x squared minus 1 times log 5 is equal to 1 minus x times log 3. And now, I'm going to take base 5 on both sides of both logs, so these cancel out to get 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And this means that x squared minus 1 plus x minus 1 times log base 5 of 3 is equal to 0. And this gets me to x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0, meaning this is one equation, x minus 1 equals 0, meaning x is equal to 1, and if you solve this, you get x is equal to negative log base 5 of 15. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 80. So to solve this, I'm going to first start by subtracting 80 on both sides. So I get a to the power of 3 plus a squared minus 80 is equal to 0. Now I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. So I simply wrote negative 80 as negative 64 minus 16. And now, negative 64, I'm going to rewrite that as negative 4 to the power of 3. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16, I'm going to rewrite as 4 squared. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if by using these two properties, I'm going to end up with a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. And this simplifies to a minus 4 times a squared plus 5a plus 20 is equal to 0. So now this gives me two equations. I get a minus 4 is equal to 0, and a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, a is obviously equal to 4. And for a squared plus 5a plus 20 equals 0, I'm going to use the quadratic formula, but I'm actually not going to waste your guys' time by actually doing it. So if you do end up doing it, you get that a is equal to negative 5 plus or minus the square root of 55i over 2. And the reason, actually what you should get is a equals negative 5 plus or minus the square root of negative 55 over 2. And the square root of negative 55, I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace I with the square root of negative 1, I get a is equal to negative 5 plus or minus the square root of 55 I over 2. So that's how I got square root of 55i. Alright, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1 over 3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number, because 9 to the power of 1 is 9, and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent and b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4, because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution.